All right, class, in this particular example, we're going to be looking at applications of systems of linear equations. So here we are looking at SAT scores. So Mishka and Ben's combined SAT score was 2290. Ben and Ashley's combined score was 2,530. Mishka and Ashley's combined score was 2,600. So find each student's individual SAT score. So we know that we have to kind of identify who these three individual players are. So let's take a look. So X will going to be represent Mishka's SAT score. We'll have Y represent Ben SAT score. And then Z will represent Ashley's SAT score. So all of these are representing the scores. So I know that Ben combined is 2290 with Mishka. So I have X plus Y is going to be 2290. I know that Ben and Ashley's, which is going to be my Y plus my Z, is going to be combined to 2530. And then I know that X plus then Z is going to have a total of 2660. So here I do have three variables, three equations, but very similar to the one that we did in that last page, we can tell that not all of these have the three variables in one. So I need to decide, all right, which variable am I going to eliminate and which ones am I going to keep? Let's go ahead and start off by, I'm going to pick to eliminate Y. So I'm going to first pick the first two equations and I'm going to eliminate Y. So this is going to be my A formula. So here A, I'm going to ignore that last one. I'm going to have X plus Y plus 0Z, that placeholder for that Z, is 2290. Now, this next equation also has a Y, so that's why I'm getting rid of Y. So I can use those two. So I have 0x plus Y plus Z is 2530. So I'm going to combine both of these. So I'm going to multiply by that second equation by a negative. So just, instead of writing it in, just remember that that's a negative. So here I'm going to have x minus 0x, which gives me an x. Here I'm going to have my y's y minus 1, so that goes away, that goes away. And then I have 0 minus z. And then I'm going to have 2290 minus 2530, which gives me a negative 240. So here is my new equation. All right, let's take a look. Now we want to use, now that we have x minus z, what's nice is I can actually just go straight here and look at my last equation, because remember, I'm just trying to eliminate one variable. Here I have x and z. So let's go ahead and combine these two and get rid of z, since I have that positive z and that negative z. So I'm going to have x minus z equals negative 240. And then I have x plus z equals 2660. I don't have to do anything, again, because they're already opposites. So those go away, and I end up with x plus x, which is 2x, equals now 2660 minus 240. That's going to give me 2,420. Divide both of these by 2, so I end up with 1,110 is our x. Okay, so now let's go ahead and, now that we have our x value, we're not done. We need to figure out what the other values are. So I pick one of these two equations to figure out what my z value is. All right, so here we're going to go ahead and plug it in. So we have 1,100 plus z equals 2,660. Subtract 1,120 from that, and so we end up that z is equal to 1,450. So now this is a special case because of the fact that I only have two variables, so I don't necessarily need to plug both x and z in to get y because none of the equations have all three variables. So I can just use the x to find y using this first equation, x and y. So I would have 1,110 plus y equals 2290. I would subtract the x and I end up with y equals 1,180. And that's it. And so I could have plugged in the z easily into the y plus z to find that out. It's really up to me. I have some options here. So now, because this is an application problem, we want to make sure that we answer this application problem with words. So we would say the SAT scores are distributed as follows. So remember, that was x, 1,110. And then we had Ben scored, Ben was y, 1,080. And then we have Ashley. $1,450. And then that's it. All right, let's take a look at this next one. So now we're looking at coins in our wallets again, except now this one, compared to that last example we had, this one we have an additional quantity because we have all pennies, nickels, and quarters. So we're going to have to break this up into nickels, pennies, and quarters. So let's go ahead and let x be the number of pennies. Y is then going to be the number of, let's say, nickels. And Z will then be the number of quarters. So always important for us to identify those. All right, let's take a look at this question then. So 33 coins in her wallet. So this means that all the coins counted for how many items there are is going to be 33. So this is indicative that the number of pennies plus the number of nickels plus the number of quarters is going to equal 33. Okay. The total value of the coins is $3.41. Okay, so total value, that tells me that I need to come into contact with the value of each item. So a penny, which is x, is going to be 1 cent, so 0.01. X plus y is a nickel, so it's going to be 0.05y plus 0.25 for the quarter, which is z, and that's going to equal a total of 3.41. Okay. And lastly, it tells us the number of quarters, remember quarters is z, is 4 less than the number of pennies. 4 less than, so that means that z, right, the number of quarters, is going to be the number of pennies, x, minus 4. So here are our three equations, so now we need to go about and solve these to figure out how many of each coin does she have. So if we take the first two equations, and we can combine these to eliminate. Now notice that last equation only has z's and x's, so we're going to want to eliminate the y. So these are going to be our first two. So the first thing that I would do is actually do what I call decimal bust, right? It's very similar to fraction bust. We're going to multiply that bottom. Let's go ahead and multiply that by 100. And so when I multiply that by 100, I have x plus y plus z equals 33. And then I have x plus 5y plus 25z equals 341. Oh, that decimal kind of got lost. There we go. So remember, even though it's pretty nice and easy to get rid of that x, we need to keep that x. We need to get rid of the y value. Because our last equation doesn't have a y. So I can do that by multiplying the top. Let's multiply that top equation by -5. Okay. And so in doing that, we're going to end up with 5x negative 5x minus 5y minus 5z is equal to negative 165. And then I have x on the bottom plus 5y plus 25z equals 341. Let's combine those items and notice that our y's cancel out. So I got negative 5x plus x, so that's going to give me a negative 4x. Negative 5z plus 25z is going to give me a positive 20z. And that's going to equal negative 165 plus 341 is going to give me a positive 176. Okay. All right, so this is my second equation. Now, looking at here, we're going to use that in this equation. So now the only difference is that we need to kind of move this around so that we can use it. So notice that if I move this around, I'm going to end up with negative x plus z equals negative 4. And then I have negative 4x plus 20z equals 176. So let's go ahead and get rid of the x's here. So I'm going to take this top equation and I'm going to multiply it by, let's multiply by negative 4, because when we multiply by negative 4, that turns into a positive x. So then we'd end up with 4x plus 4z, negative 4z. Negative 4 times a negative is a positive, and so that's going to give me positive 16. And then I have negative 4x plus 20z equals 176. My 4x's go away. I end up with 20z minus 4z, which gives me a positive 16. And then I end up with a positive 16 and a positive 176. So I add those two, I get 192. I dropped the variable, whoops. 192 there. And so we're going to divide both of these by 16, and I end up getting z is equal to 12. Now that I know what z is, I can find out what x is using this equation here. So I know that I have negative x plus 12 equals negative 4. And subtract this over, so I get negative x is equal to negative 16, which means that x equals 16. And lastly, we have our y value, so now we can go ahead and plug it in. Let's go ahead and use this first equation. This first equation here. So I'm going to have x, which is 16, so I have 16 plus y plus z of 12 equals 33. So we're going to combine the 16 and the 12 and then subtract that from 33, so we end up with y equals 5. So again, because we have a situation, an application problem here, let's go ahead and answer this in words. So we're going to come over here and say that Jada has a total of 16 pennies, 5 nickels, and 12 quarters. Okay. And then that's it for that problem. All right, let's take a look at this third question here. 3 solutions contain a certain acid. Solution A contains 15% acid. Solution B contains 5% acid. Solution C contains 40% acid. Okay, so that's the breakup of the containment of acid. Okay. A chemist combined all 3 solutions to create a 60-liter mixture. This is talking about the quantity of what we have, containing 29% acid. Okay, so let's break this up into solution A, solution B, solution C. So we're going to label our variables. So X will be the amount of solution of A. So we have the amount of solution A. Y is going to be the amount of solution B. and Z is going to represent the amount of solution C. Okay. All right. So I know I'm mixing these three things. So I want you to like visually imagine these beakers coming together to combine. So I'm going to end up with the amount of X needed plus the amount of Y needed plus the amount of Z needed to equal 60 liters. So all of these, right, the amounts of solution A, B, and C is all in terms of units. This is all in liters or milliliters. Okay. So a chemist combined all three solutions to create 60 liters containing 29% acid. So the final product is 29% acid. Okay. But it's 29% of the 60. So it's not just 0.90 like we would in money. This is going to be 0.29 of 60 because it's 29%. So the percent is percent of what? It's the percent of the 60 milliliters. Okay. So now that 15% of acid, right? So it's going to be 15% of the amount of X plus now 5%. 5% of the amount of Y, and lastly, Z, which is the 40%, 0.4 of Z. So those are our three solutions adding together to create that 29% of the 60 milliliters. Now let's look at this last equation. If twice as much of solution C as solution A was used, how many liters of each solution was used for the mixture? Twice the amount of C. So this is going to mean that Z is going to equal 2 times X. So why is that? Because if solution C is twice as much as solution A, right? And I know this because I'm using twice as much as C as I am A. This is telling me that this is going to be, if X is 2 liters or 2 milliliters, then that means that Z is going to be twice that. So it's going to be 4. So it's going to be 2 times X. All right, let's go ahead. Now that we have our equations, let's go ahead and solve this. I get to pick what I want to, how I want to combine these to get rid of. I'm going to combine these first too. And we're going to combine them and get rid of Y so that I can use this last equation. So here is our A. So I'm going to have X plus Y plus Z equals 60. And then I'm going to have 0.15X. And actually, I'm just going to get rid of the decimal. So let's go ahead and get rid of that decimals now. So if I multiplied this whole equation by 100, right, those decimals would go away. So it'd end up with 15X plus 5Y plus 40Z equals, and now it's going to be 0.29 times 60 times 100, which gives me 174. Okay. All right. So let's go ahead and we want to get rid of Y. So that means that I'm going to take this top equation and I'm going to multiply it by 5, but I'm going to multiply it by -5 so that I can get rid of the Y. So this turns into 5X, and it's negative, minus 5Y minus 5Z equals -300. And then end up with 15X on the bottom plus 5Y. All right, let's combine these. When I combine these, notice that my 5's cancel out, so I end up with 15X minus 5X. That's going to give me 10X. And then 40 minus 5, that's going to give me a positive 35Z. And then negative 300 plus 174, that's going to end up giving me a negative 144. Okay. All right. So now let's go ahead. Now that I have this equation, we're going to use this bottom equation as well. And we're going to move this one over. So this is going to be negative 2X plus Z equals 0. Okay, so I'm basically just moving that 2X to the other side. So I'm going to combine that with the 10X plus 35Z equals the 144. Okay. So now in looking at these, we combine here. So we have 10x minus 2x, 3x minus z. And so here we're going to end up with, we want to get rid of one of these variables. So let's go ahead and get rid of z. We're going to multiply this top equation. Let's multiply it by negative 35. All right, so in multiplying it by negative 35, we're going to get a positive 70x minus 35z equals 0. 10x plus 35z equals 144. And so our z's cancel out. I get 70 plus 10, that gives me an 80x. And that gives me a 144. So I'm going to divide both sides by 80, and I end up with x equals 1.8. Hold on, class. I think I messed up when I multiplied by 100. So 0.29 times 60, this is going to equal 17.4. And so when I multiply this by 100, this should have been 1,740. And so this would have been a positive 144. Yes. But then this would have been 1,440 positive. This would have been a positive here. This would have been a positive there. That would have meant that this would have been 18. Sorry about that. All right, so x equals 18. So now let's go back. Now that I know what x is, let's figure out what y and z are. So I know what z is. All I have to do is kind of come back over here to use this equation here. So z equals 2 times our x value, which is 18. So therefore z equals, it's going to be 36. And now we need to figure out what our y value is. And so our y value, we go back and let's pick that first equation. So we're going to end up with x plus, x is 18. So we're going to do 18 plus y plus 36 equals 60. 18 plus 36 minus 60 gives us y equals 6. All right, let's see if I can squeeze in our sentence here. So what does this mean? So because we are combining, and actually I wrote this wrong earlier, 60-liter solution, so that means that our answers are in liters, not milliliters. So we're talking about liters here. So this would mean that we would end up with, so our solution consists of, we would have 18 liters of solution A. Then we would have 36 liters of solution B. And, oh no, wait, solution B is 6. And 36 liters of solution C. And that would have been our total. And that's the end of that problem.